Okay. Today we are going to start the fluid and thermal system. Okay. The objective of this section are conservation of mass principle in hydraulic and pneumatic systems, not the thermal one. Okay. Ne bu ya? Sürekli problem oluyor. Mass principle in hydraulic systems. Okay. What's the conservation of mass, Daria? Okay. Anyone knows? Hmm? Yes. The conservation of mass can be used to what? To drive your equation of motion, right? And so we will drive the resistance and capacitance value for the what? For modeling the our hydraulic systems, okay? Because we know that if we have the hydraulic system, we need to add the resistance and capacitance and what? The fluid or the mass in order to build the our dynamic equations. Okay, and after that we should write the dynamic model of hydraulic systems. Okay, these are the objectives. And so we will start with what? The conservation of mass. Just remember the analogy modeling. Hajar, what's the analogy? Anyone remember this concept, analogy? No. The analogy means that we can write the hydraulic systems in terms of what? The electrical components or the mechanical components. This is the analogy. Okay, and so we have in the fluid system we have the across variable, pressure value, right? Because we apply the pressure into these systems, and also we store the mass, and we have the true variable which is equals to the what? The m dot, flow rate, right? We have these three parameters in order to build your equation of motion. In the mechanical system, we apply the force and we store the position, and so this position is derived from the what? The velocity value, because we accelerate the velocity or we can create the velocity. This is the true variable, this is the storage variable, this is the across variable. Okay, so we can store the m and we break the balance using the what? using the P pressure, and this creates to what the m dot, the flow rate between two components. Okay, so this is the case, and then we can build the our basic problem based on the what, based on the hydraulic one. Suppose that we have this tank system just like this one, and also we can create what the m in dot in here, and so we can define the P out as the P ATM, because as always we should use this one because the atmospheric pressure is everywhere. Okay, and so also we can write the resistance in here because it's a pipe, and so the narrowing the rate of the what the pipeline induces to the what, to the resistance. It resists to what, to passing flow at this case. Okay, so we can write our equation of motion based on these things, and so this is the A, area of the what, our tank, and so we can store either the H dot in here. This is the what, the height of the water or the fluid in here, or we can store the mass, m, storage rate. Okay, so in here we can derive what the m out dot can be written in here because the flow is passing to the what, to the outside, and also we can derive the P out value as equals to the P ATM, right? Because the atmospheric pressure are applied on the at two sides, input and output. Okay, and so how we can write this equation of motion in here? So firstly we need to apply the conservation of the mass rule at this case, but how we can do that? Hajar? Anyone?
Mx equals to m.
Yes, but we have also another parameter in here. No, we store the sum value of the what, the fluid, and so we have the input m in dot must be equals to the what, m store dot plus m out dot, right? Because if we have the input in here, and so we can store the sum fluids at this case because we have the resistance value, and so we can output, or we can generate the output based on the what, the m out dot. Okay, this is the first rule, and so this is the what, the conservation of the mass, right? These are basic inequality or equality for the what, for the solution of the R systems. And so what is the external input in here? This is the external, right? So we can define as to this value as an input variable. What's your name? Elida. Why we should call it the input? Yes, and also we cannot model this parameter because this coming from the outside, right? Okay, so in the second case we should write what the m in dot is external, and also we can say that this is the input. Okay, and so how we can define this MST and H value in here? As we know, we apply this system to the what? To the pressure, right? So how we can write the pressure of this tank? PST. How we can model it? PST can be written as to the what? Huh? No, not mg. H. Hmm?
P out plus.
No. Just look at these parameters. If we have the stored fluid, just remember that we have the density rho, G, and H, right? It's the pressure values for this tank, right? At this point we have these pressure values, and so if we have this information, and so which parameter is dependent on the time at this case? Rho is dependent on the time or not? G, H, right? Okay. And so PST dot is equals to what? The rho G H dot, right? These are the equation. So how we can write the MST dot in here? How we can do that? Yes, rho times A times H, right? But if we have the dynamic or the derivative with respect to the time, and so this H must be derivative, right? These are the equation. And so we have these parameters. Our dynamics coming from this equation, not otherwise, okay? And so we need to rewrite to what? To MST in terms of the what? The pressure one or height one, right? How we can write the MST dot in terms of the PST dot? Just see in the third we have this PST dot is equal to the rho times G times H dot, and so H dot is equal to the what? PST dot divided by rho times G, right? Or MST dot can be written like G A H dot, right? G times A times, and so H dot is equal to this one, and so we can write it the PST divided by rho times G, okay? And also we can say that this rho removes to each other, and so we have A divided by G times PST dot, right? This is the our first equation, okay? Do you understand that? No. Why? Ne alakası var oğlum? Daha az önce anlattım ya. Anlamadım bunu. Bir daha bak bakayım şimdi. Just look at the first equation. First equation gives us to the water conservation of the mass. Okay? That's all. If we apply the input, and so we can store and we can out the some parameters in here. And then M in dot is equals to the what? External. And so these are the input because we cannot model it. But we can model MST dot. MST is equals to what? Rho times V, right? Volume and density. And so, if this is the case, we can write this equation, right? And so, the pressure is equals to what? Rho times G times H. This is the basic formula coming from the physics, right? And so, if this is the case, we can combine these two equations and we can reach to this R equation. Just like this one. This is simple. Okay? So, if this is the case, and then we should apply to the what? To the conservation of mass, because we know that the M in dot is equal to what? The MST dot plus M out dot, right? And so, how we can write the conservation of mass? In this case, M in dot remains the same because it's the input variable. It's coming from the outside. But this MST dot is equal to what? A divided by G times PST dot, right? And also we know that the M out dot, which is given in here. But how we can define the M out dot? How we can define it? Just see that we have the P storage or the pressure of the storage, and also we have P out is equals to the PATM. And so how we can drive it? M out dot. İlayda.
M dot inland, M dot first.
No, you need to use what the pressure values. Just remember the analogy.
P after is PST.
Huh? But if you don't remember these things. We have the resistance in here. In the electrical system, V times I R, right? What is the analogy of the P in the fluid system? Yes. And so what is the analogy of this R? This is the R, right? Resistance. No, R. What's the analogy of this R? This is the resistance. This is the loss energy. In this case, we have the loss energy with what? With the pipeline, the resistance. And so, what's the values of this term right now? Yes, that's simple. And so, this m dot is the what? Is the delta P in and out, right? And so, if this is the case, and then so m out dot is delta P divided by R. But what is the delta P in this case? Just see that we have the P storage, right? And also at the outside we have the P out, right? And so if we write the PST minus P out, this is the R formula, right? But is it? Is it? This is true? No. The PST also is affected the PATM value, right? Because if this is the case, and so we have rho GH plus P out, PATM, right? Okay. So, if this is the case, this 2P out removes to the each other, and so we will reach to the what? The M in dot is equals to the what? A divided by G times PST dot plus PST divided by R, right? And so, if we want to derive the R transfer function or the state space, we need to what? Left alone to the what? PST dot. And so, in this case, PST dot can be written just like this one. G divided by A times M in dot minus PST divided by R. Okay? These are the case. And so, also, this is equals to the what? The equation of motion. Right? These are the equation of motion. Okay? You get it? Do you understand what I'm saying in here? How we can derive this equation? Any question? Just see that we have the M in dot in here, A divided by G times M out, and so we can rewrite the M out dot in here, and so we can reorganize the equation and we will get it. Just simple math. Just see. In order to collect this equation, and so M in dot minus PST divided by R is equals to AG PST dot, right? And so if you multiply the GA, M in dot minus PST divided by R, AGA is equals to the GA times AG times PST, and so this removes, this removes, this removes, this removes, and this equation. Okay? Any question? In this case, we need to know that we define it, but we have the resistance in here, and also we have the G divided by A parameters in here, which is equals to the what? 1 divided by C. This is equals to what? The capacitance, the inverse capacitance values in this case. And so if this is the analog, and so we have the capacitance and the resistance value, and then if we have this phenomena, if we define the 1 divided by C, this equation comes with a what? The PST dot is equals to what? The PST minus 1 divided by RC plus M in dot times 1 divided by C. Okay? These are the equation. And C is equals to the A divided by G. Okay? But how we can drive the capacitance value? Derya, could you help me to drive it? We need to drive it. Huh? Could you help me to drive the fluid capacitance formula in the fluid system or the hydraulic systems? Huh? Başka bir zaman diyor. Yeah. And so the main question is that how can we calculate the capacitance of fluid system? Hacer yoklama kağıdı başlatsana ya. Bir tane abi. Yok olmaz ya. Sadece işte sistem dinamik, tarih, grup kaçsa kaç, isim soyisim.
Hocam ben kendi grubumda belirliyorum.
Hiç önemli değil. Okay, what is your name? Kendi grubunda olmayan Meryem kardeşim. Evet. Just help me Meryem. Okay? How we can drive the capacitance of this value? R, and also we have defined to these parameters. So we know that what is the pressure? Pressure is that rho times G times H, right? That's it. So in order to define the capacitance value, just remember the mechanical formula. In the mechanics, the capacitance is the inverse of the stiffness, right? K times X. That's it. In the electrical system, we have the across variable or the applied variable is equals to the what in the electrical what? Voltage, right? Right? Voltage. Okay. And so, what is stored in the electrical system? Huh? İlayda? Huh? Q, charge. And so, if this is the case, just remember the cıvık, right? And so, this is equals to what? 1 divided by C, right? So, in fluid system, we have to what? The applied variable to what? Huh?
Area.
No. What is the across variable? Which? Huh? Yes, pressure. And so what is stored in fluid system? Yes. And so we need to find out this parameter, right? And so we have the pressure formula in here, just like this one. And so this is the pressure. But we need to write this equation in terms of this one. We need to convert these values into the M in here. Pressure is the same. It's the pressure. So in this case, the M is equals to what? The P equals to the question mark. It's equals to what? The rho times V, volume. But the volume is equals to the what? A times H, right? And so this is written as the rho G H is equals to the question mark rho times A times H, right? Mariam. And so we can remove the what? This rho value in here and also H value in here. And then if we have the A and G value, this question mark is equals to the what? G divided by A, right? These are what? The conclusion. See? But just see that P is equals to the question mark times M, or Cp is equals to the M, which is coming from the what? This analogy model. And so this is equals to the what? G divided by A is equals to the 1 divided by C. And then we can conclude that this C can be calculated as the what? The A divided by G. Do you understand this formula? Anladın mı? Emin misin? Okay. That's it. We can derive what our capacitance value based on what the shape factor, A divided by G. But it is coming from the what? This equation. Do you understand that? What's your name? Mert. Do you understand this concept?
Anladım hocam ama sadece CP eşittir M'e nasıl anladık onu anlayamadım. CP eşittir M'e nasıl bulduk onu anlayamadım.
This value.
Evet.
This is the capacitance, and so we apply the pressure. It's equals to the M, because in this case Q is a charge parameter, and so C is giving to the left hand side, and so C times V is equals to the Q. This is the benefit of the what? Using analogy. That's it. And so, if this is the case, we can write this value in the standard definition, in the book definition. We can write it. In the standard def, the C is equals to the dm dp, which can be set to be to the what? For a given pressure, how much mass can be stored? Capacitance means that for a given pressure, how much mass can be stored in this system. This is the what? This is the R dynamic. And so this C is defined with the what? The derivative of rho A H and D rho G H, and so A G. This is the standard definition. The other one is the derivation of these algorithms. Okay? And also we can draw to the what? To graph of this term in here, just like this one. We have the pressure value, we have the mass value, and also we have the curve in here. And so this, the tangent value of this curve is the C. Okay? That's it. Do you understand right now? Do you get it? This is the geometrical depiction. This is the standard formulation, but this is the derivation. Daria? Okay? Okay. So, in the third place, we need to talk about the fluid resistance. It's not easy to find the fluid resistance, but we can apply some approaches in here. If you did you take the fluid mechanics lesson up to now? Okay. So, from the analogy, we can write it. The voltage is equal to the I times R, right? What is the analogy of the voltage value in the hydraulic one? Maria? Yes. And so this is the R, and so this is the M dot, right? This is the analog with the what? With these denominations. And so, in the standard definition, we can write that the resistance value can be calculated with the what? The dP over dQm, or dP divided by dm dot. Okay? This is the standard basic mathematical definition about the what? About the resistance value. Okay? And so, we can derive this in terms of the what? This is the derivation, right? This is the derivative. And so, this is the what? M dot. This is the P. And we can take the MR dot and PR dot. This is the reference value. And so, we can draw this. And so, the tangent values is equals to what? Is equals to the R. That's the basic definition, right? Daria? That's so simple. You don't need to worry about anything in the system dynamics. Okay? But if we have these conditions, and so just remember the mechanical system, we can connect any elements into the parallel or series, right? Do you remember that? What's your name? Abdurrahman. Okay. So, Abdurrahman, if you remember these terms, and so if we have these two conditions, just like this one, we have these pressure values and also resistance one, and also we can define this term, but we have also a P3, P2 and P1, right? This is the resistance R1 and R2, right? So how we can write these two resistors into one? This is series or the parallel. Why? Why?
Together the same room.
What's the condition of the definition of the serial? Huh?
Şeyi bölüyor olması olabilir mi?
Yes. Just see that in this case, if we apply the P1, right? P1. The P1 is only affected on what? R1. P1 is affected from the R1 and also P2 is affected, but after the R1. Okay? This is the series. At the same time, we cannot affect the P2 and P3 in here because it's series. And so, in the hydraulic systems, we can collect these R values just like this one, P3, and so this is the general R, and R can be defined with the R1 and R2, okay? Just like in the electrical analogy. But if we have this value, M dot, is applied on the what? This resistance value, just like this one, R1 and R2. And also this is the M dot. And so, how we can collect this one? This is the parallel or series, Meryem. Why?
Önce ikiye bölme ve ikisinden
Yes. M dot affects two components at the same time. This is the condition of the what? We can say that it's parallel or not. Derya. Okay. And so how we can combine these values? How we can generate the R, collective parameters? Huh? Huh? Yes, or 1 R over R, R1 and R2, right? So we can say that this is serial or series, this is the parallel, right? That's it. So in the fluid system, we can apply some approaches to define the resistance value in the laminar flow. What is the meaning of the laminar flow? Anyone knows that? Yes, but how is it smooth? Just I can write that if laminar flow or no turbulence or the average particle velocity happens, what's the meaning of the turbulent? Turbulent. Just how can I say that? I don't remember the English words. Kasırga, hurricane, hurricane. Just in the hurricanes, everything is on the water turbulent flow because there is no pattern at this case, right? But in the flow, maybe sometimes we have the continuous movement at the particles of the fluid, and so we cannot see the change in the fluid one. we can see it as a what? The solid. But it flows all the time. This is called laminar. Okay? We can apply this condition to the what? To the fluid systems. Just like this one. 1/28 mu L divided by pi rho d over 4. But this is happens only the what? The cylindrical tubes. Okay? We have in here this is the fluid viscosity of the fluid. This is the length of the pipe. Okay? And also this is the water diameter of the pipe, and this is the water fluid density. And this is the basic formula for the what? For our resistance calculation. It is the approach to what? To define this laminar flow. Okay? Any question? Do you have any question? You understand everything in here? What I'm saying? Not you. You. Hiçbir şey anlamadım. Anladın mı her şeyi? Dürüstlüğün için teşekkür ederim en azından. Anladın mı? Ama sorun varsa sor. Tamam mı? Senin de derse katalım yani. Okay. Let's continue with the dynamic system. But we should define to the what? 7.4 dynamic models of hydraulic system. First of all, we need to draw to the what? Example system. But I draw this as a complex case. Okay? First of all, this example can be built with the what? With this tank. Okay? Also we have the pump in here, just like this one. And also we have a tank, and also we have the resistance value R1, and also we have another resistance value R0, because we have a pipe in here. It's narrowing, right? And so this is R1 and this is R2, and we should define another tank in here, and also R3, 2 should be given in here. Okay? And so we can store the what? The fluids at this case. Also, we have the P pump values. This is the pump, and so we apply the pressure, right? And so if we put what? The cable of this pump into the electricity, and so this electricity generates the what? The pressure values. Abdurrahman. That's it? You get it? Okay, thank you. And so, if this is the case, we can add another parameters in here. This is the what? The QMI. This is the input flow rate. It's coming from the outside. Okay? So, how we can solve this system? In order to solve this system, first of all, you need to write the conservation of the mass based on the what? The mass flow rates. If you obtain the whole flow rates in here, and then you can solve easily this equation or this system. I'm sorry. And so we can define to the what? MST1 dot, because it's the first tank. Secondly, we should write MST2. This is the second tank. Okay? And so we have the A1 and A2 in here. This is the area of the tank, and also we can say the what? This is the H1, this is the H2, right? Because it's the height of the volume. So we have the storage values in here, but we have also input values, M O dot. This is the input flow rate to the first tank. And also we can write the M1 dot, this is the output of the first tank, but the input of the second tank. And also we can write the M2 dot in here, because this M2 dot is the output of the tank 2, right? If we write everything just like that, and so we can solve it. But in order to solve these equations, we need to write the analogy of the electrical models. If we have the pressure values in here, what is the analogy of this pressure in the electrical one? Elida. Yes, this is the voltage, and so we can build the ground in here, and also we can build the what, the P pump or V pump. It's the voltage value, right? And so this voltage is applied on the what, the resistance, right? In the electrical system we have also resistance in here, R0. See, this is simple. And so after that we have a tank. If we have a tank, and so we have the storage elements, which is, yes, we have the capacitance, right? C1. And so if this is the case, we have a tank R0, and so this capacitance is connected with the what? With the R1, right? And so we can draw the what, the R1. And so this R1 fits to the what, tank 2, and also we need to drive or draw, at this case, to the what? Huh? Yes, cap 2, C2, right? And also we should write that if we have the, this is the feeding values in here, this is the output, and so some of the capacitance is consumed with the what, with this R2 value. Okay, and so we need to correct it, these terms, because if we have these parameters, and so the C2 in here, but also we lose to what, the some other current in here, because the R2 is what? Yes, R2 is connected to this ground value, because we lost some fluid value based on the what, the R2 value. But also we had the QMI value in here, guys. How we can edit? This is the what, the source, but what is the type of this source?
Current source.
Yes, this is the current source. QMI, right? But in this case, this is the I, because it's the electrical analogy. So how we can write it? In order to solve this equation, we can use the Kirchhoff law, right? And so we can define, this is the I0, this is the I1, this is the I2, right? And this is the I4, and this is the I3, right? And also this is the I5. We can write it, and so at each parameter we can solve the Kirchhoff law in here. This is the voltage 1, this is the voltage 2. Okay? This is the electrical analog. Either we can solve the left part or right part. These are two equals system dynamic equation in order to be solved. Okay? So we should continue with the what? With the fluid one, because this is the case for this lesson. Hajar, firstly we should write to the what? Conservation of mass, right? How we can write the conservation of mass based on these equations? We should write the whole the fluid rates, mass flow rates in this case. How we can write it? Just see the this is the fluid value, huh? Huh? Yes. And so how we can write it? What is the input of this first tank? Yes. which is equals to the what? Yes, 1 plus. No. No. Yes, because in this case we feed the what, the m0 dot, and so we can store and we can going to the what, the outside for this case, because we have a capacitance in here. And so in the second case, this m1 dot plus, yes, how we can add the QMI?
It's P storage.
How we can add the QMI? This is the external input, right? And so if this feeds to the H2, and so also we need to write the m dot in here. This is m dot, right? Yes, because we have the two inputs in here, P pump and the out flow rate, right? So this two equation gives us to the what, to our representation. And so in order to write the R dynamics, we need to convert everything. mst1 dot is equals to what, the mo minus m1 dot, and also mst2 dot is equals to the what, m dot plus m1 dot minus m2 dot. This is our rules to what, to derive the R equation of motion, guys. Okay, that's so simple. Just apply the conservation of the mass rule. So in the second case, how we can write the mo dot? Ilayda, just help me. I can help you. This is the R, but which R should be selected in here? Yes, because the m0 is applied on the r0. But how we can write the upper part? Yes, but how we can write the delta P? No. What's the left hand side? What's the, no, there's no PATM in PATM is equals to 0. Yes. And minus what is the pressure of this term? No. Huh? Yes, P storage 1. And so what is the m1 dot? What's the resistance values of this term? Yes. And so yes. What is the m2 dot? What is the resistance? R2, but no, not M storage, P storage 2. And minus, no, PATM is 0. And so that's all. PS2. Okay? If we have this formulation, and so we can put these equations into the conservation of mass, and so we will obtain the every equation related to these values. But just remember that how we can write the capacitance formula in here. Just remember that mst1 dot is equals to what, the C1 times pst1 dot, right? And also mst2 dot is equals to C2 times pst2, right? Just remember the R formula. That's it, right? Did you have any question about these things? Huh? Okay. And so if we use this equation, and then we will reach to the what? To this one. In the third place, we need to write the equation of motion. Just like this one. C1 times PST1 dot, which is equals to the P pump minus PST1 divided by R0 minus PST1 minus PST2 divided by R1. This is the what? M1 dot. This is the what? M0 dot. This is the storage part. C2 times PST2 times, which is equals to MM. This is the QMI, right? And also plus PST1 minus PST2 divided by R1 minus PST2 divided by R2. Okay? That's it. This are the dynamic equations. And so, in order to write in proper form, we can write this one. This C1 is divided by the right hand side, and so we obtain the PST1 dot is equals to the what? PST1 times minus 1 R0 C1 minus 1 divided by R1 C1 plus PST2 times 1 divided by R1 C1 plus P pump is equals to the what? 1 divided by R0 C1. This is just a reorganization of the whole equation. And also PST2 dot is equals to the what? PST1 times 1 divided by R1 C2 plus PST2 times minus 1 divided by R1 C2 minus R2 C2, okay, plus MM dot times 1 divided by C2, okay. These are the equation of motion. But now we can write the state space equation in here. What is the states of this form? What is the states of this form? Huh? No. What is the derivative term in here? Huh? And so x is equals to the what? PST1 and PST2. Okay? Okay? Huh? Yes. No. 2 times 2 matrix should be given in here. Okay? Because we have 2 states. Okay? So, how we can write it? First of all, we need to write to the what? To this one. This is the Z1. This is the Z2. This is the Z3. This is the Z4. And this is the Z6. And this is the Z5. Okay? These are the what? The symbolic representation of these terms. And so, after that, we can write the whole equations in here, just like this one. We have x dot is equals to what? The ax plus b u. Okay? And so, what's the values of the x? X is defined in here. Okay? And so, how we can write the a value? Just see that we have 2 times 2 matrices in here, but with the values of the what? Z1, Z2, Z3, Z4, right? And so what is the B? Yes, but we need to write 2 inputs in here because the U is equals to the what? P pump and also M dot M, right? And so the B is equals to the what? Z5, 0, 0, Z6. Okay? These are the state space representation of the R formulations. Okay, that's it. It's so simple, but we need to organize the whole equation based on these terms, right? Okay. In order to more understand these values, please solve the 7, 4, 6 in the book. Solve 7, 4, 6 example, and also solve 7, 4, 7 example, and also solve 7, 20 problem in the problem section, and solve 7, 30 problem in system dynamics book. Okay, fine. Okay.